Mitchell, an American computer scientist. More formal definition is a computer program is said to learn from experience E with respect to some class of task T and performance measure of B of its performance task T and as measured by P improves with experience E. Okay, I hope you can understand that. This definition of task which machine learning is concerned offers the fundamental definition of the field of cognitive terms. In generic definitions, machine learning can learn by its own without explicitly programming the machine. Central to the machine learning is the concept of automatic decision making without the user specifying explicit rules. The second central concept is generalization. The goal of the machine learning model is to predict new and previously learned or unseen data. Okay, the talk for today, actually we are presenting to you the toolbox, the tools that machine learning or data scientist should have. First is foremost is Numpy. This is for numerical computing and linear algebra operations. Pandas for data cleaning and exploratory data analysis. Matplotlib and Seaborn for data visualization. ScikitLearn for machine learning algorithms. And I'm not presenting on slides. My slides are all notebooks. I'm using my Python or Jupyter Notebook. This is for our environment here. So later on, I will give it to the organizer for GitHub. You can access the same notebooks in your GitHub. So basically, those are the 5 or 4 items that we will discuss today, and a little bit of Jupyter Notebook. Okay, by survey, this is Stack Overflow data by David Robinson. I haven't yet put in the report. So I intend that after the sorry, it's not yet in the but you contact the grants in your account and you will give it there. Okay, this is a measure of data of Python visitors at Stack Overflow. And these are the major. The bigger the circle is, meaning if there are more people visiting subject in Stack Overflow using the Pearson correlation or point. Okay. In the middle here.
So we look at the middle blobs here. In the middle, the biggest circle here is Pandas. So meaning more people, a lot of people visiting Stack Overflow, searching for these tags. We have Pandas, Matplotlib, Numpy, TensorFlow, and Keras. These are more for deep learning. ScikitLearn for machine learning. ggplot, I think this is for visualization. Over its sides, PySpark, Hadoop, this is more the big data. Down here, I think Django, and these are for web development, GitHub, and Linux. So we can see that there are a lot of Stack visitors, Python visitors searching for these tags. Okay, and next, okay, I got this from KD Nuggets. These are the top US jobs in 2018 based on salary, the y-axis, and the growth at x-axis. On top here, although less numbers is the machine learning engineer. Yeah. Oh, okay. All right, thank you. So machine learning is the highest on the salary bracket. Data scientists, a lot of jobs, and also highly paid. Near to the data scientist is an optometrist. Yeah, I think we could say that there's a correlation between the data scientist and people who change your glasses all the time. Yeah, I think we should, yeah, because we are looking to our computer all the time. All right, next. Okay, how to install Python libraries. Here I am using Anaconda distribution. So, any one of us used Anaconda? Okay, quite, all right, 5%, 10%? Okay, Anaconda distribution, when you go to the Anaconda website, I think here, yeah, you can download your, okay, you say download, whether you have a Windows machine, a Mac, or a Linux, you can download your, clicking this download button here, 3.7 or I think or 2.7. This morning somebody mentioned that it should be deprecated next year, or so you can download right away the latest version, which is 3.7 in whether Windows, Mac, or Linux. Okay. Anaconda is a free and open source distribution for Python, specific for scientific computing, to simplify the package management and deployment. Package versions managed by the system Conda. So it's an open source. So Conda is the data science package environment manager here, and you all have these libraries mentioned here. Jupyter, the notebook that we're using now. Spider, also another IDE. Jupyter Lab, we can use R even. Numpy for analytics and scientific computing. Numpy, SciPy, Numba, Pandas, and Dask. Visualization, Boca, and or the Matplotlib here. Machine learning, we are using ScikitLearn. We are not into TensorFlow yet. So this is Anaconda project, Anaconda Navigator. So when you install that Anaconda, this is the window for, after you install that Anaconda in your computer, you will find here the Anaconda Navigator. Here you can have, these are the notebooks, Jupyter Lab or Jupyter. Jupyter Lab, I guess, is still on alpha test. This is an upgrade of, Jupyter Lab is an upgrade of Jupyter. Jupyter is just purely a notebook, but Jupyter Lab, you have something else. You have more functionalities. So actually, you need to install that again here. You need to install that, and after that, you will see a launch button. So then you want to launch your notebook, then you just click this one. This is our home tab for Anaconda Navigator. Let's look at the environment. So in the environment, you can create another environment, whether you can select the packages that you want to install. But in this case, I'm using the root environment where everything is installed. Let's say not installed here, like TensorFlow. I didn't install the PyTorch. I think some of this I have installed anyway for this talk. Let's go back to home, and I've already clicked the Jupyter notebook. That's why I'm here. And okay, we're looking at the Jupyter Notebook. Okay, let's. So this is the Jupyter Notebook. For data science, I think some would say this is the preferred IDE for with Python. Jupyter is a open source web application that allows creating and sharing documents. So the most important thing here is that you can create this thing and reproduce, and you can share this document either Git, or you have something called, you can share your notebook either PDF or HTML. So in Jupyter Notebook, we can use all those Numpy, Pandas, and ScikitLearn, and Matplotlib within that notebook. So when you, as I've said, when you will launch the Jupyter Notebook, you can either go to the terminal or on that Anaconda Navigator and click the launch button. Okay, notebook operations. So this is a notebook, what I say here. Okay. Sorry. Because I haven't shown the cell. This portion is not shown in my notebook. I removed all the toolbar and the menu bar. So actually, this toolbar here was there. It's supposed to be there, and you can use these toolbars with, with your mouse or your trackpad. But in this case, I'm just using the shortcuts. In shortcuts in Mac, you just press H, and you will know the shortcut keys. You have command mode and edit mode for that every cell. This means a cell of the notebook. Okay, so this is the menu bar. The toolbar was there. So with this, you can control your cells using this. When you want to run a code, you just click this run button here. When you stop the code, stop button, save, and you move the cell up or down. Kernel is you want to clear again the output, restart and clear all output. And view, this is the header. So I just remove the header, this part where you can change your the name of your notebook. So let's go back and remove the header and the toolbar. Okay. So as I've said, when the cell is blue, it's on command mode. Let's follow. This is a cell. It's on command mode. It's blue. Turn it green. You press enter and it becomes green. So that's your editing mode. On top here, okay. On the cell itself, you can in this box here is code or markdown. When you're putting a code, you press the code here, and if you want to change to markdown, then it becomes a markdown cell. But this one, we return to code cell. To execute the cell, just shift enter, and the output will be shown below the cell. Okay, let's execute this. So I'm using a 7.1 version of Python. Okay, in the notebook, we have also magic functions. Like, they are followed by, they started by the percent, these are the magic commands. One of the things that we are using here mostly is the Matplotlib inline, which makes sure that our graph, this one, Matplotlib inline, we'll use this one later on. This is mostly so that your graph, your plots will be just shown below the cell. Sorry, let's comment this again. All right. Also, another useful magic is a time it range to know the time that your code is performing or measuring with this range from 0 to 1,000 loops. So it takes for a while. So we can stop. We can interrupt by double interrupt because it takes too long. So here we have some, to import a library like Numpy, just we type here import Numpy as np. So now Numpy is working on top of Python in this notebook. So np array range is a Numpy loop. From just now we are using the Python loop of 0 to 1,000 range. So with Numpy we're using np range to 0 1,000. It's 880 nanoseconds per loop. Okay, I think you got it. There are some loops here. So as I've said, if it takes time, you can interrupt by this stop or by double I. If it takes too long, so as I've said, we'll just remove this toolbar. Again, import Numpy, sleep. Long number here, as I've said, also to just before interrupt. Okay, the notebook. I mean the part of the notebooks they mark down. So this is a markdown when it's in code that is coded like this. Shift enter, then that is a markdown. I mean, as it's shown, you can show the mathematical equations. Also, Python, even a Python code, you can show in a markdown, and also we can show that here. So that is the Jupyter Notebook. It's not only for coding, but also for, like, when you document what you're doing and sharing it later on to your colleagues or the people who want to know what you're doing. Okay, next notebook would be let's go to the Numpy notebook. Just now I've opened them all, but apparently those are missing. Let's open again. So each notebook. Okay, introduction to Numpy. Some people call it Numpy, but since Py is Python, we just call it Numpy. So Numpy is a fundamental package needed for numerical and scientific computing in Python. It provides a powerful n-dimensional array object, sophisticated broadcasting functions, and linear algebra random number capabilities. So Numpy is built over Python. The powerful thing in Numpy is this. It's in the array class, or Numpy array. The in the array is a data structure for Numpy. For n-dimensional array, it is different from the Python built-in list data structure or the dictionary. The NumPy arrays are homogeneously typed. All elements of an array must be the same type. So mostly numeric, because since we are computing NumPy is a mostly numeric ND array. So it holds only one type. Like if it's float or integer, it should be that one only. So ND array has the following properties: collection of values, add, remove, or change elements, homogeneous data type, multidimensional, mathematical functions, support, and fast and efficient. Attributes of ND array is the np dot indem, shape, size, and data type. When it comes to computation, the three concepts that makes NumPy powerful is the vectorization, broadcasting, slicing, and indexing. So I will show them in code later on. While Python, the data structures, we have list, dictionary, sets, tuple. Let me show what are lists. This is some Python data containers. So is a list. A list is a container with enclosed in a square brackets. In this case, we are showing integers. And the next one is a dictionary. We have a key value pairs. Key value pairs. This is the key and the values separated with a colon. Tuple is an immutable structure with enclosed in a parenthesis. Actually, what makes it a tuple is that the comma here. You can remove the parenthesis and it's still a tuple. Okay, so those are the data structures in Python. Let's say what type is PyList, so it's a list. Set is also, this is the set normally is also enclosed in parenthesis. So NumPy, we start with NumPy array. We import NumPy as np. And we want to create an array from the PyList that we have, from the Python list. So now that py_list is now an array. np.array creates that list into an array. Okay, so I remember, what time do we finish? Oh, 2:15. And I'm still on my second notebook. Okay, okay, I guess we have to speed up. Okay, as I've said, so in Python, when you add these two lists, it only concatenates these two lists, 1, 2, 3. While if it's in, so if you get here, so to execute a mathematical task in Python, you have to create a for loop. While in NumPy, we have so-called broadcasting, where when we add directly this, let's say I showed it. Oh, but this side isn't there. So this list here, or an array, we have 0, 1, 2, and you're adding it to a scalar. So automatically in Python, it will add an invisible, so that they will be in the same dimension, like 3 columns and a vector of 3 elements. So we just add all five to this array. Similarly with like 3 by 3, let me execute it here. So Python, like for a 3 by 3 array, added to a single row array, it will create the same array so that they have the same dimensions. And the operation addition or multiplication is done element-wise. So I think you get that. The next NumPy functions that we can do is slicing and indexing. Let me show. Okay, let's go directly here. Even images can be represented by arrays, by numbers. So I have here a method in Matplotlib. I downloaded a image or a picture which is measured at 0 to 4,000 in the y-axis and 0 to 6,000 in the x-axis, meaning that is 4,000 by 6,000 pixels because it was taken by a 24 megapixel camera. So in Python, in NumPy, so this is represented as a multi-dimensional array, 4,000 by 6,000. The 3 here is the channels or the layers, meaning the RGB, red, green, blue layers of that picture. To show that they are shown in let's print the, so this is the representation, array representation of that picture over there. So we have an array of, a series of 4,000 arrays and 3 layers. To show the 3 layers, let me print. So these are the 3 layers here. What happened? Okay, apparently it didn't show. Red. Okay. All right. So, okay. I think we have a short time only. So that's, okay, I'll just explain all the packages. NumPy and then Pandas. Pandas is the data cleaning part of machine learning in Python. So Pandas can read external files. Let's show here. This is a favorite data, iris data from ScikitLearn or Pandas. So this is the data of that, the iris data set. You have the sepal length, sepal width, petal length, and the petal width. So this is the iris flowers. It's 3 species shown here. Sepal width, this is sepal, and this is a petal. So they measure this thing and they get this data. So in Pandas, you can determine the name. So this is the names. It can slice the name by the column, and it will give you the names of the, and also some mathematical function like group by. So it gives you that there are 50 under the name column. There are 50 of each species, like Iris setosa, versicolor, and virginica. So, but in NumPy, in ScikitLearn, the machine learning part of Python, our data set must be all numeric. So we have to change this name here, which are on strings, we must change to numeric. One of the So now we have changed the using this command by changing recode the name values into digits to integers. Head also head means it shows only the first 5 rows. If you want to look at everything, then this is the whole data set. Instead of head, you put tail, then this is the last 5 rows. So, okay. And here in this column, we don't need a name column on this data set. We only need the numbers. So we drop here the name column and in place so that it will change the whole data set permanently. And then we can write back to Excel or CSV. And if we have to iris this new, right? New. So this is our new Excel file created from the notebook. How many minutes do I have? 5 minutes or 6 minutes? Okay. All right. I thought it's not that fast. Okay. Let's go directly to ScikitLearn. ScikitLearn is the main library of Python for machine learning. So they have a very good website. I mean, with very good documentation on their website, and you can continue learning later on using that website. Okay, machine learning. We have supervised and unsupervised learning. Now they have the reinforcement learning and recommender systems, but we don't show that one here today. So supervised learning is we train the model and we have normally we have a train and test part of the data set. Supervised learning, and when the data set we have a label, and we predict from that label. Unsupervised learning, like images, they're not labeled. We just tell the machine to find what we can find out from that data set, any insights that we can learn from the data set. So data structures of ScikitLearn, we follow the Numpy dimension where we have n samples and n features. So we try to, let me look at that iris. Iris is also built into the ScikitLearn package, the iris dataset. So this is the dataset from ScikitLearn. So our targets, like a while ago, we call this a species. We have 0, 1, and 2. So 150 rows of data with 5 features: sepal length, sepal width, petal length, petal width, and target. So we have 150 samples and features of 4. Supervised learning, if this is our data set, we split the data set into training data and test data. Then we train the training data and test, and we have the model. We test the test data into the model, and to test the model if it's working properly and determined by the accuracy. So we split the data. We have a training set and test set. Also the the target will also split into a training set and a test set. Maybe I just execute everything. Is that execute? I cleared. Okay. All right. So, all right. Sorry, man. It executed everything, including my last slide. I forgot that because that notebook even can execute that keynote. Oh, okay. So, all right. Sorry, I forgot. It was in the last here, right? Actually, so just now we're shown with this. Okay, we load this. The iris data set. Machine learning, here we are using the decision tree classifier. And this is the decision tree classifier. We started with petal width, and Gini is a kind of error or impurity in the data set. Once it's Gini is 0, meaning it has accurately identified the class. So it keeps on splitting the data set and until it goes to the last class. So until the Gini is 0. Okay, so all right. So I think I go straight to my slide. I execute this. Thank you.
So packages, there are a lot. I think there are 5. Like I'm using WinPython, but I find Anaconda to be very, very heavy in terms of the size of the library itself, and I don't think that we need all of the packages of Anaconda. So is there a way wherein we can you recommend other libraries or packages for scientific Python that is not considered very heavy in terms of resources? Or can we use Anaconda in a slim mode per se?
Okay. Thanks for the question. So let's say, for example, there are some not installed here. So I mean, if you want to install this, then you can just take this square here. Because if I create now, it takes time actually. So you can use either 2.7 or 3.7, 3.6, 2.5. You can even use select the version of Python when using Anaconda. And I guess nobody use here. You put your name, a name of your environment, then you select anything. I cannot do it now because it takes time.
I sometimes have to find anomalies from sales data. So for example, we're selling shoes, and this model of shoe needs to come with this color of shoelace. But sometimes, every so often, randomly, there's a mismatch between the shoelace and the shoe. And what I want to find out is that, is there any way that we can inquire the data where we know what an anomaly looks like, but sometimes we don't know the factors that affect it. How would you go about finding anomalies in the data?
Is that like image kind of thing? I mean, you want the machine to learn the images, like shoelace or matching.
Sometimes we don't know if we're not sure 100% if this delivery was incorrect, and I want the machine to have to give me some clues that, oh, this probably is an error and you should fix it.
Maybe I'm not in that domain actually. Sorry, the business. I'm a different business. So, sorry, maybe I don't understand your question very well, or maybe the machine has to. I mean, you just want. Maybe you have need more features on that data, so you will know, because it depends on the features of your data itself. Okay.
If I generalize my question in the sense that if someone tells me, I have this data, something is probably wrong with it. For example, in rocks, there's some anomalies in the rock formations. How do you first go about finding, standardizing, and what first things do you do to know where the anomalies are?
Okay, so I'm not sure I can answer that actually, so sorry for that. I'll take note of that, and we'll come back to you on that one. And yeah, of course, but normally our data must be clean, and we have all the features in that data. And if you're in that domain, then you understand what you need to look at actually, yeah. All right, anything else?
So my question is, in all your years in the industry of extracting oil and gas from the earth, how have you used machine learning to, how have you used machine learning so that it beats manually programmed solutions?
Okay, I heard, I saw in Kaggle contest where they have a data. Because to determine if there's a salt in that reservoir or a soil formation, so if you can find, because when you find salt in a formation, you find oil. Yeah, so only because data in like geology, you have only seismic data. You introduce ultrasonic stuff, then you can get images. So that, as I've shown also, that images can be represented in the numbers. So using that image, and also you must understand how it looks like. I mean, there are programs, but mostly are proprietary programs, and not everybody can. Only the specialists can look at this. But nowadays, like with Python and other, with open source and democratize this machine learning. That's why the data scientists and machine learning and Furious just explode the usage, because we have machines that they can run faster. Okay. Otherwise, last time only the big companies have their own very big machines. So we have all the software actually, but as I've said, they are not as open as what we have now.
Good afternoon, sir. I'm Eden Lucero. I'm from Cebu, and I'm also working in the oil and gas industry. So I am very interested. So how did you start up from working with oil and gas? So how did you started to work with data science and machine learning? Because technically my work right now is I'm an application engineer for softwares, working on the data on 3D models from owner-operators and EPC companies.
Okay, for us, okay, because I've said from upstream and downstream are different. Upstream are those who develop, explore. Downstream is the refineries. When they bring this oil and gas in the downstream. And okay, we have a lot of equipment, compressors, pumps, and we are using now IoT, put sensors on the equipment and collect the data, and let's say predictive maintenance. That's what mostly we get. Online streaming, because we have online sensors. We normally it's all graphs to know the processes, how it behaves, the compressors, whether there's some sensor, high vibration or temperature or those things. So we collect all those data, apply the machine learning, and to know when should we down that equipment before it fails totally. Meaning last time we were just using live data science like a Weibull distribution. MTTF, probabilities actually, mean time to failures and mean time between failures. So now with machine learning online, I mean, because unplanned downtime is the very big thing in the industry. We want our equipment to be running all the time, but it's not always. All right, seems okay. Thanks.